Alright, so in this video, I'm going to solve the equation 4 to the power of x plus 9 to the power of x is equal to 25 to the power of x. So to solve this, I'm going to start off by dividing every term by 25 to the power of x. So I get 4 to the power of x divided by 25 to the power of x plus 9 to the power of x divided by 25 to the power of x is equal to 25 to the power of x divided by 25 to the power of x. Now the 25 and 25 cancel out for 1, so now I have 4 to the power of x over 25 to the power of x plus 9 to the power of x over 25 to the power of x is equal to 1. Now if I have something in the form a to the power of m over b to the power of m, this is equal to a over b to the power of m. So 4 to the power of x over 25 to the power of x turns into 4 over 25 to the power of x. And 9 to the power of x over 25 to the power of x turns into 9 over 25 to the power of x. From here, I can rewrite 4 over 25 as 2 squared over 5 squared. And I can rewrite 9 over 25 as 3 squared over 5 squared. And now, if I have something in the form a to the power of m over b to the power of m, remember, this is equal to a over b to the power of m. So 2 squared over 5 squared turns into 2 over 5 squared. And the same thing with 3 squared over 5 squared. So I get 3 over 5 squared. From here, if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So the 2 and x multiply. So I get 2 over 5 to the power of 2x plus 3 over 5 to the power of 2x is equal to 1. And this means that 2x is equal to 1. So now if I divide both sides by 2, I get x is equal to 1/2. So this is my solution. Please make sure to subscribe, leave a like, and share this video. Bye. Alright, so in this equation, I have 3 to the power of x to the power of 3 over 9 to the power of x is equal to 81. So, to solve this, I'm going to first write 9 as 3 squared. So I get 3 to the power of x to the power of 3 over 3 squared to the power of x is equal to 81. And if I have something in the form a to the power of m to the power of n, this is equal to a to the power of m times n. So 3 to the power of x to the power of 3 over 3 to the power of 2 times x, so 3 to the power of 2x, is equal to 81. I'm going to rewrite as 3 to the power of 4. So now notice how I have everything in the base of 3. So this is going to make it much easier to solve. Now, if I have something in the form a to the power of m over a to the power of n, this is equal to a to the power of m minus n. So 3 to the power of x to the power of 3 over 3 to the power of 2x is going to equal 3 to the power of x to the power of 3 minus 2x, which is equal to 3 to the power of 4. And now, if I have something in the form a to the power of m is equal to a to the power of n, this means that m is equal to n. So x to the power of 3 minus 2x is equal to 4. And now if I subtract 4 on both sides, I get x to the power of 3 minus 2x minus 4 is equal to 0. Now we have an equation here, and this isn't a regular quadratic equation because we have a power of 3 here, and we have a missing power of 2. We don't have a power of 2. So to actually solve an equation like this, what we have to do is we have to test out values, and then once we get a value that works out, we have to use that one value to find all the remaining values that are solutions to the equation. So let's first start out with 1. If x is equal to 1, then I get 1 to the power of 3 minus 2 times 1 minus 4, which does not equal 0. Now if x equals 2, I get 2 to the power of 3 minus 2 times 2 minus 4. 2 to the power of 3 is 8. 8 minus 2 times 2 is 4, and 4 minus 4 is 0. So this does equal 0. So 2 is a solution. To be more precise, x equals 2 is a solution, meaning x minus 2 is equal to 0. So now what we're going to do is we're going to divide x minus 2 with x to the power of 3 minus 2x minus 4. So I get x to the power of 3 minus 2x minus 4 over x minus 2. And to solve this, we're going to have to use synthetic division, and if you guys don't know what that is, I would recommend watching a YouTube video on it. So our coefficients of our numerator is 1, -2, and -4, and then we have a 2 over here. I'm going to bring down 1. 2 times 1 is 2. -2 plus 2 is 0. 2 times 0 sorry, I actually did something wrong. We should have a 0 in here because, remember, we have a power of 2. So because there's no power of 2 here, we just put a 0. Now, if we bring down 1, we get 2 times 1, which is 2. 0 plus 2 is 2. 2 times 2 is 4. -2 plus 4 is 2. And 2 times 2 is 4. -4 plus 4 is 0. So we have a remainder of 0, and we get x squared. Our coefficient is 1 plus 2x. Coefficient is 2 plus 2 at the end. So I get x squared plus 2x plus 2 is equal to this. And this also means that x minus 2 times x squared plus 2x plus 2 is equal to 0. So for this equation, I get x minus 2 is equal to 0, and x squared plus 2x plus 2 is equal to 0. For x minus 2 equals 0, x is obviously equal to 2, and we already got this solution before, so this is no surprise. Now for x squared plus 2x plus 2 equals 0, to solve this, we have to use the quadratic formula, which is -b plus or minus the square root of b squared minus 4ac all over 2a. So I get x is equal to -2 plus or minus the square root of 2 squared, which is 4, minus 4 times a, which is 1, times c, which is 2, all over 2a, so 2 times 1. And now this is equal to -2 plus or minus the square root of 4 minus 8, which is -4 over 2, which is equal to -2 plus or minus the square root of 4 times -1 over 2, which is equal to -2 plus or minus 2i. Square root of -1 is the same thing as I over 2, which is the same thing as -1 plus or minus I. So my three solutions to the equation are x equals 2, x is equal to -1 plus I, and x is equal to -1 minus I.